Welcome, everyone. It's good to be among old friends again, and also to meet quite a few new friends, people who this is their first conference. How many of you are here for the first time? Yeah, loads of you. It's great, really exciting. I hope you've enjoyed yourself anyway. If you haven't, let us know and see how we can improve things. And for those of you who are new and have no idea who I am, I'm Roger Orr, as you can probably guess from the name on the slide. I've been programming for more years than I care to recollect. More recently, almost entirely in C++ as the primary language. I'm the head of delegation for the UK to the ISO C++ body, and also on the direction group. So as I like to put it, I know enough C++ to be dangerous. But the longer I go on doing this, the more I try to find the simplest thing that could possibly work. And that's partly what this talk is about. Now, who's come across Betteridge's law of headlines? Which is, if you ask a question in a headline, the answer is always no. It's not quite true, but you might have thought of that. You could just say no and then go and find another talk to go to, but you might want to hang around a bit and see what I get to talk about. So the first thing is that C++ has got quite a long history. Who was using C++ in the 1990s? Yeah, okay. So who was using it in the 1980s? Yeah. Who's using it this year? Yeah. Who's wondering whether they're in the right room? Yeah, that's okay. No one's here. And it changes. Languages change. One of the things I'm struck by when people learn a language is you learn a language at the point where you learn it, obviously. And you can now get your job done in the language of choice. But things have a way of changing. But do you necessarily learn the new ways of doing things? Sometimes you do, sometimes you don't. You can get the job done with what you've got. There's a lack of motivation to learn a new way. So sometimes I think you can probably guess when someone learnt a language by the natural way they write their code and which features of the language they use. Question from the back? No? Okay. The other thing is you get the people that are always on the bleeding edge. And whatever's new must be better because it's new. And sometimes I think it's good to take a step back and reflect on what we're doing, how we're writing it, why we're writing it, and what the repercussions are. And similarly, if you're writing a library or a header file or something, who gets it right first time? Any hands? No, I thought not. So we tend to iterate over internal headers, we generate libraries, we generate algorithms, and we have kind of version 1, version 2, etc. And we want to make it better the next time. Sometimes we can throw out, so to speak, the baby with the bathwater, and we've got a narrow focus on what better means, and somebody's use case gets broken, as we heard. It's getting long in the week. I can't remember which talk it was, but it was the idea any change breaks someone's use case. And there's a couple of examples of that in the talk. So, as the dust sort of settles on C++ 23, it's all over bar the printing at this stage. I was reflecting on some of the lessons that we might look at with the way things have changed in doing one or two things in C++. What might help us choose which is the right idiom to use? Now, what's the right answer? And the answer is there's probably not the right answer. It depends. A classic consultant answer. It depends. You know, who's on your team? What languages do you use? What other languages do you use? What's the background? What constraints do you have on compilers? So how many people in the room are currently programming with C++ 23? 1, 2, okay. Me occasionally. C++ 20. Okay, quite a few more. 17. A few more. I'm getting old. 14. Yeah. 11. Yeah. 98. Yeah. So that depends, and you might think there's a really lovely feature I'd love to use that's available in a compiler I haven't got access to. What do you do? Not much you can do, really, apart from learn how to do it the other way. So I thought I'd start with something that we all know and love. Who's heard of a for loop? Yep, that's good. So let's say we've got a simple task to produce the product of a vector. Produce product, oh dear, a typo on slide 1, that's never a good thing, is it? A vector of integers. And here's how you might have written it in C++ 98 days. You've got a function called product. It takes a vector by constref, and you start with a result of 1, and you just go around items.size, multiplying by the element you found. Okay? Do you think the for loop is correct? Anyone have problems understanding the code? Okay. What's not to like? A couple of hands at the back, yeah? Sorry? Integer overflow. Yes, there is a bug, potential bug. Result star equals items I. What might happen if you've got a big vector with lots of numbers in? Might overflow. I decided not to go that way because that's another talk. But looking just at the plain loop. Of course, if you're writing modern C++, you wouldn't write it quite like that, would you? I'm sure, given the number of people in this room, there's at least 17 different ways that people would recommend you now write it. So we'll look at 2 or 3 of them. The first thing is, bear in mind that this code is understandable. Nobody put their hand up to say it was unclear what it does. So if we do make a change to the code, is it still understandable to as many people as the original code was? And one of the reasons for that is, with a little bit of a change to the syntax, the same code would probably compile in other languages. Basically anything with curly brackets. There's nothing much that's particularly C++-ish about the loop itself. Not a huge amount anyway. Which again means if you're using multiple languages in your project, it's easier for you to grok this. It's not going to have anything you're going to trip over in your understanding. But before we go on to refactoring the loop, why do we bother with a for loop? I mean, you know, we know that under the covers, you know, everything goes down to assembler code, so it's all Gotos, right? Who works somewhere with a policy of no Gotos in your code? Anywhere? Yeah. Yeah, I fought against that one place and I lost, so there were no Gotos. Under the covers, it's all Gotos. That's the same code. In fact, I tried it on Godbolt, and the first 2 compilers I tried, it generated the same assembler. Exactly, you know, instruction for instruction. So why don't we write code like that? Anyone prefer this to the for loop? Yeah, nice for loop. Go forward. I mean, that's much lower level, isn't it? And much, therefore, faster. No. The problem is we've lost any sense of what's actually going on here. You have to reassemble the loop in your head. There's been a recent discussion about whether const extra, we've got this thing that when you write a range 4, it gets rewritten. When you write a for loop, you have perhaps a break statement. And if you look at the wording in the standard, a break statement is a bit like you had a goto. You're not allowed gotos in a const extra context. And someone said, oh, this is bad. It sounds like, according to the formal wording, we couldn't have any loops in const extra. We better look at changing the wording. And someone said, well, hang about, why don't we just allow goto in a const extra context? Why not? And a couple of the implementers said, because it's really hard. A generalized goto, where does it go to? How do you do your structured analysis you need to do to prove in a const extra context nothing undefined is happening if you're allowed arbitrary control flow? And it's very hard to automatically process that and say, oh yes, that's a good use of goto. So we use a high level, I mean, admittedly, a for loop's not desperately high level, but we use a high level construct. It generates the same output, but it's clearer to the reader. And as has been said at least twice this week already, what's the purpose of source code? You've got 2 audiences. You've got a big audience, which is all the other people that read the source code, and you've got a very small audience, which is the chip. and you want to keep both of them happy. So possibly if you did a code review of that old for loop, you might make a couple of small changes. You might prefer to use std size t rather than int. Who'd vote for std size t rather than int? Any votes in favour? Yeah. Any votes against? Yeah, again, it depends a bit on context. We might prefer to use brace initialization for result. We might not. We might use brace initialization for index without anything in the brace to mean 0, because everyone knows that an empty brace means 0. Yes, no, depends on your context. Who are you programming with? Is that just going to be something that will make your other team members stumble? Or will everyone else look at it and just go, I know immediately what that does, and it's consistent to use empty braces to mean whatever the 0 is for a data type. So even these sort of simple decisions you make as writing code have an implication in terms of the expectation of the other people who are reading your code. And of course, everyone knows that loops you have not equal rather than less than. Possibly. Again, who thinks that's an improvement to use not equal? 1, 2, 3. Who thinks it's worse? About the same number. Who doesn't care? Yeah, fine. So you can just go through your code base, change all the less thans to not equal, and then next week go back and change it back. Oh, and a plus plus IDX, because of course IDX plus plus is, bad. It's an int, or at least a size t. Does it make any difference here? Anyone think it makes a difference? So, yes, there's a hand.
Yeah, the plus plus on the other side is a temporary.
Yes, you're correct. It generates temporary. Fortunately, for an int, the compiler can probably, almost certainly will, completely elide it. But the advantage of getting into plus plus in your mindset is you do the same thing with other data types, like iterators, where it actually generates an object. So I think it is worth getting into the habit of using plus plus int, even though here it doesn't really make any difference. Because you might then refactor the loop to have some object where there is actually behavior in generating this temporary object. The almost always auto school of thought. Who's heard of almost always auto? Yeah, I thought so. Who uses it? A few. Who hates it? Okay. We've got a lot of reasonably even polls here. It's quite fun. Again, you think about what the implications are for your reader. I mean, does the chip care? No. The compiler that works it out, whatever it works out, is what you actually execute. Do your readers care? Yeah. Does your future self care when you come back and look at the code and think, what data type did I really think I was getting here? I can't remember. Conversely, you make a small change, and if you're not using auto, you may have to go through and make a ripple effect all the way down to change the type. And with auto, it all just changes automatically. Hints in the name, really. Which is better? Fish. It depends. Here, auto result 1. I think that's fine. 1's obviously an int. Of course, auto is 4 letters and int is 3. So if you don't like the keyboard, you might want to stick with int. But if it was double, of course, that's 6 letters. So, you'd obviously want to use auto because it saves you 2 letters to type. But also it means if you change that to 1L, to at least reduce some of the overflow, you automatically get the data type changing without having to change both int to long or long or whatever. You could be a bit twee. Auto IDX 0UZ. Who's used the UZ suffix yet? Yeah. I found a compiler that supported it. You're familiar with putting a U after a number to mean unsigned, and L for long and all that sort of stuff. And we've now got Z and UZ for size T and kind of diff T. So you can then go AutoIDX is 0UZ, and that says to the people who know that it's a size T. Okay. Supposing you wrote that and showed it to your colleagues, how many of you would have some puzzled looks from your colleagues? Yeah. How many of you, the colleagues, have already showed you this code? Yeah, it depends on the context you're working in, and keep that in mind the whole time. I'm going to keep repeating that, so I apologize. You could, of course, change it in a more exciting way. Because you might think it's, well, let's go backwards. You know, why not? What's not to like? And there are cases where this might be sensible. If we weren't doing a multiply of ints, but doing something with double precision numbers and they were sorted, it might make more sense to do it in largest numbers first or smallest numbers first. We change the loop. Who likes that loop better than the one before? Anyone? I mean, what's not to like? We've saved some checks. It's slightly shorter. We've taken out any need to put anything in the post increment because we do it in the condition. Quick question. Should it be IDX minus minus or minus minus IDX? Are you sure? Who thinks the code here is right? Who thinks the code here is wrong? Who would like to go away and play with it to find out? Yeah, yeah. And one of the beauties of using an idiom is that everyone else can read the code and immediately they just know it's right. You've done a for loop in the normal way. Now, maybe you've got a use case where this sort of reverse loop's common, in which case in your environment, maybe it's a common idiom. But in general, people are going to have to think a lot harder to understand what that does. And the second issue, was anyone else at ACCU some years back when Walter Bright talked about what every programmer should know about optimizers or something similar? He was, maybe still is, a compiler writer, and he did a talk on, as a programmer, how do you write code that the optimizer will do a good job on? And one of the things he pointed out, which is kind of obvious in retrospect, is if you stick to common idioms, that's much more chance that the person who wrote the optimizer will have thought of your use case. If you do some weird idiom that hardly anyone else has used, there's much less chance that the optimizer will recognize the pattern and do something clever with it. So you might think you're making the code faster because of the way the loop optimizes, but it may not work quite as you think. So what do you do with optimizing when you want to know if it worked? You check what the output looks like and you measure it. Normally, I try to do double-blind measuring, where I don't know which version of the program I'm testing. So I don't lie to myself that this one's faster. I do the test with prog A and prog B, and I say, oh, prog A is definitely better. Oh, that's the original code. Okay, well, I'll stick with that then. Because too many times I've persuaded myself that if I ignore that outlier, this is much better, and then... How about this one then? You realize that there's no reason to start with 1 because you could just take the first item and multiplying it by. So you save 1 extra multiply by 1 if you do something cleverer. If it's empty, you return 1 because that's the kind of boundary condition. But if not, what you do is you start with item 0 and then iterate around the rest of the loop, just multiplying. Who is sure that this code is correct straight away? Who would like to think about it a bit longer and be a bit worried about some boundary conditions? Yeah, yeah. I did run a couple of tests just to prove I hadn't done something that would make me really embarrassed in public. Although I do drama, so I'm used to being really embarrassed in public. Oh, I must have copy-pasted it wrong. What have I got wrong? Oh, yes, I'm missing a parentheses. Well spotted. That's very strange. I must have deleted it after copying and pasting it into the presentation. Oh, well, stuff happens. Spontaneous destruction of a... So, who likes this? Not many. Under what conditions would it be worth changing the code to do this, if any?
Well, it provided an important performance improvement.
If it provided an important performance improvement. So, How do you know it's important? You measure it. Thank you. And hopefully you've done some measuring first to see that this is the bottleneck. Now, one of the things we've got in C++ is the STL iterators. So a lot of people would prefer an iterator solution. So rather than going around a for loop with an index, you go around with a const iterator from items.begin to items.end. Everyone happy, I assume, with that sort of code? Everyone fairly confident that what it does? Anyone worried about any particular boundary conditions with the code? As far as I could tell, this seemed pretty obviously correct, leaving aside the overflow issue we've already decided to ignore, because overflow never happens, right? The thing that I find a little bit distasteful is you've got star equals star, which can be a bit confusing. But, you know, we're used to that now. Hey, we're C++ programmers. We get stars in front of our eyes all the time. Who prefers this to the old for loop, the other for loop? Who prefers the original index-based for loop? A lot of people. Who doesn't really care? And those who aren't asleep haven't put their hands up because you wouldn't. Of course, you want to be more modern. You use cbegin because that's giving you a constant iterator, and cn for the same reason. And of course, you use auto to avoid spelling out the type. Even the people that don't like always use auto do like using it for things like iterators because you just save so much noise. Going back to the old one, I had to split it over 2 lines, mostly because of std vector int const iterator, which is quite long and really adds nothing to my comprehension of the program. If I need to know the type of it, I just need to know the type of items, and that's there 2 lines further up. And it's not that relevant what the type it is, it's an iterator. It's the right iterator for the job. Who prefers this one, using cbegin and cend? Yeah. How many people regularly use cbegin and cend? Yeah, it's good, happy to get into. But again, it's one of the cases where when you learnt the language shows, how many people learnt it when there wasn't a cbegin and cend? And so your kind of muscle memory, brain memory, you kind of do begin before you've even really thought about it. And it's good to keep reminding yourself of cases like this. C++ 11 added cbegin and cend. So it was just partly to give the ability of the writer to express more clearly that they wanted a const iterator. And it also fits nicely with auto because you're now getting a const iterator. You don't therefore have to spell it out in the type on the left-hand side. You spell it out by putting a C in the cbegin call. And the nice thing about an iterator solution is you can generalize it to things that aren't necessarily random access. So I can make it a template with some collection type. I can go through, iterate through the collection, same algorithm as before. Nothing down here has changed, but it's now generic. You can do it through a list of integers. One little problem. Anyone think of a potential problem with this?
You've not constrained the container type.
I've not constrained the container type. This is true. I could try and instantiate this against who knows what, something that doesn't understand begin and end. What happens if I suddenly invoke it with a container of complex numbers?
It works fine.
It works fine. Does it do what I expect?
Probably not.
Probably not, yeah. So again, once you generalize something, you need to be a little bit more careful because you make assumptions. And the assumption is that for the star operator on the thing I'm iterating over, 1 is the thing I start with. Well, for many numbers, it would be. But I also assume that it's an int. And maybe I want to do the same algorithm over a set of doubles. So you'd have to generalize the int, maybe do some other generalization. Again, that's a side herring from the main talk I'm doing. There's also, of course, now in new ways of doing loops. So we can just iterate over everything in items by using range 4. For AutoItem : items, result star equals item. Again, it looks nice, it's easy to read. Anyone got any confusion in their head about what it does? Is it better or worse than the first example with for I equals naught, I less than?
Yes.
Yes, good answer, Alan, yes. What's benefits it got? It's absolutely obvious you're iterating over the whole collection. You're also hiding the whole iterator mechanism. You've just got item. You haven't even got, remember I said about that star equals star bit that's a little bit messy? That's gone away. Under the covers, it's dereferencing, but you don't see that. You just see item. Any potential problems with that code, particularly if I started turning it into a template that you might think of? You'll see lots of hands up. Anthony, I think you were first. Yes. One of the problems with auto is people then think, I don't need to think about the type at all. So you get a copy. Here, we're iterating currently over a vector of int. Does it matter whether we take a copy or a reference? Well, which might be faster? Maybe in this case, it might be better to take a copy, possibly, but I suspect a reference and a copy will probably generate basically the same code. But supposing we're iterating over an array of strings, vector of strings and doing something, and we start taking a copy of a string, that could be a little bit more expensive. There was a proposal, N3994, that you should better omit auto. And it would just use AutoRef, which many people thought was the most obvious and best default. But many was not enough. And there was a long discussion about whether that was the right default and how you would do something else. And sadly, after Microsoft had implemented it, it then got turned down in plenary, which I still feel bad about because I didn't raise a national body objection kind of early enough. But sadly, it would be quite nice to be able to do that and not worry about having to remember to go, which is best? AutoRef, AutoRef, AutoConstref? Sean Parent. Who's heard of Sean Parent? I'm hoping a few hands will go up here. Yeah. Some years ago, he came and did a talk here, and he was put against one of the well-known ACCU speakers. And so we had like 10 people in the room for Sean Parent speaking, which was terrible. It was a brilliant presentation. But anyway, he's got a phrase called no raw loops. And he says, I've put the link in here and you can get the slides later, that use an existing algorithm if you can, rather than writing your own loop. And again, in general, if you're solving a problem, there's a fairly high chance that the kind of algorithm you're trying to use, probably someone else has stumbled across in the last 50 years of IT. And it's possibly available either in your standard library or available through a bit of a search. So use a standard algorithm if it's there. A friend of mine has an interview question for C++, which is, he just says, name 6 standard algorithms other than sort and find, which are the 2 people always come up with. And there's loads of them. And each version of the standard comes out with a few more. Look through them, try and work out what they do, when you might use them. What's the advantages, if there are any, of using a standard algorithm? Anyone got any suggestions?
Everyone knows them.
Everyone knows them, apart from they don't. Everyone can look them up. CPP reference in the manual. If you use a standard algorithm, who's done the debugging of the standard algorithm? Someone else. The other way is to implement a known algorithm as a more general function, and then maybe contribute it to perhaps an internal library in your company, or maybe put it up on open source, maybe even write a paper, propose it for standardization, give talks, become famous. Oh, maybe, but it'll happen to some people. So let's try and see what happens if we apply no raw loops here. Well, here's a simple way. We could use algorithm. There we are, I'm using stood for each. That's an algorithm. Job done. Who thinks that's an improvement over the previous code? Anyone? It uses an algorithm. I mean, go on. Be nice to me. Oh, okay. Yeah, and for each, I struggle to find good use cases for each. Now we've got range 4, but it is an algorithm. You got one? Parallelism. Ah, yes, good point. We won't go there. Parallelism stood for each with extra types. But a different algorithm. Let's use accumulate. Who's come across accumulate? Great, wonderful. Who's used it? And nearly the same hands, even better. Who found it was buggy? Oh, 1, 2. Yeah. Was it easy to use? Does the name speak to you about what it does? No. Depends on what words you use and what your vocabulary is and whether you think accumulate means something special. It's not a great name, but it's a useful thing. So it goes through everything from begin.end, and you pass it value, and it invokes something, some functor on it, which in this case we use std multiplies. With earlier versions of C++, you had to put something in there to get the right instantiation of std multiplies. And then STL came up with this paper that said, well, actually, we could overload it for default template argument of void and have a nice method inside that works on all types. And he managed to get the paper approved and right through the whole process without any changes. So he got a round of applause when the plenary vote happened because that's so rare. But it makes life a lot simpler. And again, not having to name the type means that if we changed at some point to use a different data type than int, again, we haven't got to change it there. Or another different algorithm. This is a newer one. It's in C++23. It will be in C++23. Currently, it's implemented by one compiler's runtime, which is Microsoft's. So I was able to compile this, and it works. And the question is, do you think that fold left speaks to you more clearly than accumulate?
Yes.
Yeah, I do. Who prefers accumulate? Yeah. Okay. So again, you know, there's not necessarily a single right answer. The nice thing about the ranges one, of course, is you don't have to go begin and end. You just give it the thing, items, which is quite nice, I think, because you don't have to worry about have I done begin and end on the same thing? Bad things happen if you go, oh, begin from this collection and end from that one. It'll end somewhere, but probably not in anything other than tears. And again, supposing, you know, in a few weeks' time, you get your shiny new C++23 compiler and you go through your code base and change all uses of std accumulate to ranges fold left. Will your friends and companions at work love you or hate you? Hate, probably. Yeah. So gradual adoption of things, having a good reason, maybe using it in new code rather than just going through and making gratuitous changes. Also, what's the likelihood that one of the changes you make will accidentally introduce a bug? 100%. 100%, yeah. I think you've probably got the scars, have you? Yeah. So to summarize what we've looked at with a for loop. Nice and simple. Many ways of writing even something as simple as a for loop. What's the best way, and there isn't a right answer, of expressing your intent to your audience? The compiler knows what it thought you meant, which may even be what you meant. But what did your colleagues think you meant? And if you use non-idiomatic, and again, idiomatic to one person is, whoa, what's that, to somebody else. But if you use non-idiomatic constructs, it's harder to reason about. And you want people to better read your code, look at it through, and spot the bits that are tricky, and ignore all the other stuff. It just wants to be simple to understand. And if you hide the loop completely, it's one less thing to think about in the code. Okay, any comments, questions from the back?
Yeah, I think you haven't mentioned what the best way is, which is reduce.
Yeah, there's a way would be reduce. And again, one of the things about looking at different ways of writing something is you realize you could go on for hours, but I want to get on to some other subjects. So, slightly different change of topic, constraining templates. So take our earlier example with our product, and we've made it into a simple template. This time I've used template parameter for the collection and a type name of view. And I've got a product that takes a collection of views and goes around doing accumulate. Again, you need to give more thought here to the one in a general case, which is off topic for what I'm looking at here. Prior to C++20, you'd have had to have put type name in before col_u value type, because you needed to tell the compiler that it's a dependent type. But since C++20, that was fixed down with type name, which I think you had something to do with, yeah. And prior to C++17, we needed to use class for the template type name inside. We couldn't use type name because somebody forgot to add that in, basically. So again, depending on the age at which you learn the compiler, some of this stuff might still be the way you don't write it. But that, again, looks fairly simple, works quite well, but it's not constrained on anything. So if you try to instantiate it against something odd, you're going to get some pretty weird errors. Or you may, of course, want to use a deduced return type and just make it auto and just do whatever the return does. But, okay, well, good. Vector of ints, that's where I started. Everything's okay. A vector of strings, I'm going to get an error. Why am I going to get an error? Anyone? I'm trying to go multiply by 1. What happens when you multiply a string by 1? Doesn't work, doesn't compile. You might say, well, that's just tough. If somebody uses my carefully constructed product in a bad way, they get what they deserve. Doesn't worry me. But you may want to give a bit more useful feedback to the user. And in particular, you may want to have a completely different product that does something else for different data types. So we may wish to spare people the errors that you get out of the compiler, and we may wish to give people better options of overloading. So the original way that smart people came up with was Standenableif. Who's used Standenableif? Yep. Who found it entirely obvious to use? And yeah, a couple of people did. Okay. First time you see it, you think, what's going on here? And then you gradually kind of get your head around it. So you have to, it's now in C++11, you hash include type traits. In this case, I use Standenableif _t. I apologize for the fact that the underscore and the underlining have sort of trod on each other's toes here. So Standenable if t is all one token. If it's arithmetic, then we're good, because we can multiply. And if it's not, then this isn't going to compile. This won't be available in the overload set. So you won't get an error message that refers to the details of the implementation. You'll get an error message that tells you something doesn't match. Yep.
What does it mean to multiply bool?
Good question. What does it mean to multiply bool? Yeah. Again, when you're a library designer, you have to start asking questions about how much effort is worth putting in to catering for all the corner cases. How many users have you got of your library? How many people here have ever written some code that you could loosely call as a library header file? Yeah, a few. Okay, so for all those that haven't put their hand up, the number of people that use your type is presumably just like you. So as long as you can remember what you did, which is getting increasingly difficult, but if you can, you don't really care because you're going to use it correctly. How many people have got a library that's used by, say, less than 100 people? Yeah. How many people have got a library that's used by, say, 1 million people? Okay, so we're somewhere between 100 and 1 million. So again, you have to think, I'm spending development time to further constrain it against, in this case, bool, but there are other things you could think about that you might want to constrain. But how much effort is it worth putting in? If I'm implementing the standard library, it's probably worth putting in a lot of effort because there's a lot of programmers who will hit. They do some weird things, programmers, in case you hadn't realized. People will probably try all these boundary conditions accidentally, and it's good if you've thought about them. If you're writing a smaller library or one used in-house, the person who comes across the problem will just come and bang on your door or send you an instant messenger. So it may not be worth over-engineering it. It might be. With concepts, since C++20, you can now use a requires clause. How many of you have actually used concepts kind of in anger, or hopefully not too much anger? Yeah, only a few. I thought it might be more than that. How many of you are compiling in an environment where you could use concepts? Yeah, a few more. The nice thing about concepts, as we'll see, is that you get some extra benefits from the fact it's a language feature rather than basically a library feature. So what you do is you take the template type name that we had before, and then you just go requires stud is arithmetic underscore v of u. And that now means that it won't instantiate if that constraint is not satisfied. But unlike enable if, that's part of the overload set, resolution rules. So if you've got another template called product, and it will all fit in nicely in the overload rules, and you don't have to worry as much about cases where you get ambiguity or things not working or just getting instantiation failure, because it finds the one with the enable if and tries kind of binding to it. And you also can get some quite nice error messages. This one came from me trying to play around with this and see what you actually got. And the arrow, it actually says in the error message, the candidate function requires is arithmetic v of u. And it even tells me somewhere where type u is. So it gives me a clear message with the name of the constraint that's not satisfied. Hint, sometimes it's not quite as good as that, but this was a particularly good example. Or we can use a concept in the parameter list. In this particular case, we have to define a concept because although is arithmetic is part of the traits library, we don't yet have a concept for it. So we can define our own concept. Template type name C concept arithmetical is stud is arithmetic underscore v of c. And then we can just use arithmetical as the type of the second argument. So it's fairly clear that what we're saying, I've got a template here, the first argument is some sort of template parameter, and then there's this arithmetical type u. And this gave me an even clearer error message. It said the concept arithmetical stud string evaluated to false, which is great feedback for me as a attempted user of the product function as to why I can't call it against a vector of stud string. Naming things is really powerful, as I'm sure you're perfectly well aware, and having a named concept can be really, really helpful. And there's a set of concepts in the standard library, but you might want to add some more, to your own, whatever your particular domain is. So some advantages are, as it's a language feature, there's kind of less boilerplate, better interaction, as I mentioned, with overload resolution, and there are reports that you get much better compilation times with concepts because they are part of the core language than with enable if, where you're generating lots of template stuff only to throw it away again if the constraint's not satisfied. And I was trying to think of a good example of when the old way would be the best, and at times when you really should use enable if. I must admit, I couldn't really think of a good case, but I can see a hand coming up from Alistair at the back under the light.
I'm not sure if this use case falls out of what we're talking about, but when you're supporting a base of users that do not yet have access to
Yes.
broad user base.
Yes. If you've got code that may be using older compilers, then using the new feature will lock them out. So it's again a case. How many of you out of interest are writing code that other people are consuming and you haven't got control over the version of compiler they're using? Yeah, quite a few. So you have to make a decision. Okay, it's going to be cheaper and easier for us to support this range of compilers, but it then stops these customers who are on the old compiler. Is the risk worth it? Alternatively, you might be able to do some sort of conditional stuff based on the C++ standard that a person is using. But then, of course, you've got to write the code twice and test it, I hope, twice. So again, there may not be a simple answer. Okay, any more on constraints and stuff before we move on? Okay. I then thought I'd pick another example from streaming messages to and from memory, which is relatively common. And we're hopefully all familiar with the streaming idiom from Hello World. Who's ever written a Hello World program? Yeah, you're among friends, it's all right. But your streaming paradigm is quite a powerful one, and it can be used for streaming all sorts of things. I think I can't remember the name of the product. There's one that does streaming paradigm to get things in and out of databases. It's a paradigm we're kind of used to thinking about, and it's quite powerful. And people often use it for logging. Who's ever worked on a project that used streaming for logging? Yeah. Of course, some of you might not know you were because it was hidden behind a macro, and you didn't ever bother to look inside the macro to see how it worked. But it is really, really common because it's very powerful. So we want to log some sort of information during the execution of our program, and the streaming paradigm gives us a kind of nice, easy way of doing that. It's easy to buy into by adding streaming implementations for your own data types. Often buried, as I said, inside a macro, but sometimes expands to something like this, where you end up within your code, you stream into something, OSS, the input and the number and the produced and the result with some data type, and then maybe you add the line number as well, and then that gets logged in some logging framework. All good so far. Back in the old pre-98 days, so those of you who had your hand up for using it in the 90s and the 80s probably remember StressStream. Who's used StressStream? Yep. Who still uses StressStream? Couple of hands still up. Yeah. So you created an output string stream, OStringStream. You streamed into it, and then you logged oss.str. Okay? Everyone happy with the code? No. Correct. You should not be happy with this code. Does it look right? No. Ish. If you know enough, you know it's not. If you don't know enough, it looks right. And what's more, you get the message logged. Well, normally logged that you expect. Problem is, there were some issues, and I'll come to those in a minute. The other way around is when you're reading data in. So you might use an input stream to read data out of, say, a string you obtained out of a configuration file or got off the network. So here we've got an area configure call where you pass in a value as a string, and we just stream out from there the width and the height. Fairly straightforward code. There are all sorts of issues you can come up with that as a design, but it probably works well enough. Round trips reasonably nicely if you're careful. And that, again, is something that a lot of people have done. Probably fewer than the output side, but how many people have used OStringStream or something like it? Yeah, a few. So the example I had earlier, the pitfalls with StressStream, and they're very, very easy to fall into, and you can go a long time sometimes without realizing you've done this. There's actually two bugs in this one. The first is that OStringStream requires you to actually put an end of string in the buffer that you're building up. So you have to put a null character on the end manually. So you have to stream out a std ends. Everyone knows end all, but there's end s as well for end string, or put a 0 in yourself. And it also memory leaks, unless you call freeze false, which perhaps they should have called it Thor, but whatever. Because what happens is when you call str, it says, oh, I'm now releasing the contents of this string. I better freeze it so it doesn't change, so I don't get any problems with like stale references. But if it's still frozen when the destructor's called, it just gets leaked. Bit of a design flaw, I think. Perhaps that was an error. I'm fairly sure it was an error. Easily done to make a mistake like that. And of course, as the person who designed it, you probably always use it correctly, but other people don't. So again, it's, okay, this is a bit bad. We've got something that quite a lot of people use. I mean, probably about half the room would put their hand up. But there's a couple of obvious flaws with the very old way of doing it. If you forget the end S, what do you probably get? Well, it depends, doesn't it? But in many environments, a lot of the time, except in the demo, there's a 0 happening to be there in memory anyway. So it does the right thing. So it's a kind of one of those dangling bugs that will pop out at the wrong moment. And similarly, how much memory do you leak from a log line? Well, it's not going to be that many bytes, is it? Your program might run quite a long time before you realize you're leaking memory, but it'd be better not to. So it was superseded in C++ 98 with StressStream, which is a bit odd because the header name is shorter, but the class name is longer. Go figure. So we create an OStringStream now rather than a StressStream. And the streaming bit's just the same. It's a destination for streaming operators. And what we get back from the str operator is actually a stood string. But sadly, our log method was some ancient C library, so we have to go .str on it to get the const char star out. And it guarantees a terminating null, and it also guarantees that it won't leak memory. So what's not to like about this? Well, the problem is, I said, and you may have missed it unless you already know the answer, oss.str returns a string. It actually does that. It returns a string. So you've created a string, which we then call c_str_on, go and log it, and then throw it away. So we've got the overhead of, we've created a string stream, populated it, and then copied all the data into a string, which we then throw away. I think if you really worry about the performance of your logging, you may have got bigger problems, but in general, people in C++ land are somewhat concerned about performance and memory use, and this is bad. So a lot of people avoided using OStringStream in many places for that very reason. Despite the fact it was much safer to use, this particular niggle stops a lot of people using it. And similarly, on the input side, you can use an iStringStream, and you just give it value rather than value.c_str. It takes the string and you stream it in, everything's nice and good. But it's this problem of string duplication. People don't like it. And possibly when StressStream was put together, a bit more thought could have been given to, are all the people currently using the StressStream header going to be happy with what we've provided? And possibly something could have been done then to help with that. But of course, it's very hard to predict. I don't know whether anyone even really thought about that at the time, or maybe there was a lot of concern, but no one could come up with a good way of fixing it. But one of the things, again, to think about if you're writing a library and working out a new API is, well, what have I changed? Are there use cases that I don't support as well any longer? And is there anything I can possibly do to mitigate against that? Because otherwise, I'm going to find that people are going to carry on using the old API until I pull it out of their hands by main force. So C++ 23 still has them in there as deprecated. Okay, that's 25 years. That's quite a lot of time to deprecate something. I think actually it should have been removed, and I think it was an oversight because the paper that Peter Summerlad wrote to provide a way of doing what StressStream did better did actually talk in the front matter about deprecating StressStream, but that didn't get into the formal wording, sadly. So maybe someone who does papers about deprecating things in the standard, Alistair, might want to put a little note together somewhere about deprecating them and just removing them completely from the deprecated section. So what Peter added was move semantics. So you can now use log of STDmove of OSS.str. And what that now does is when you call str on a moved from stream, it just moves, as the name you'd hope would mean it would do it, it moves the string contents out into this temporary string, takes it out of the OStringStream, so there's no more memory allocation going on, and then the temporary goes away and it's all tidied up. So this is now just as efficient as the old code was, but still has all the benefits that you always get it null terminated and you don't have to worry about the memory leak. So this was a very simple change that's given us a benefit. However, how many people here have ever done STDmove on an OStringStream? 1, 2, 3, okay. Well, hopefully, on Monday when you get back to work, maybe some more of you might add an STDmove on an OStringStream in use cases a bit like this. Or you may just not care. It's in logging. It doesn't happen very much. Similarly, on streaming to and from memory, in the old days, you could use a fixed buffer. So we've got a cunningly known as fixed buffer I've just created on the stack, 40 bytes in length, because there's constraints on how long messages can be. I mean, in an ideal world, we wouldn't ever have to worry about how long error messages could be. But mostly, you have to care a little bit. How many people are working in an environment where log messages that are too long just get truncated or don't appear at all? Anyone? A couple of people, or have worked in ones. So you may have I mean, 40 bytes is a bit of a silly number, but it meant the slide would fit. So make it a 40 byte limit. Create an OStringStream with the fixed buffer and the size of the fixed buffer, and now you can keep streaming in, and when you fill it up, it will just stop. So you won't overwrite. Of course, I've got a potential issue. If I don't get the ends on, then I've got a fixed buffer without a string terminator. So again, you've got a potential problem, but at least it will only be at most 40 characters in length. And don't have to do the unfreeze, yeah. And there's no actual memory allocation going on. It's on the heap, on the stack. It's just used. You know, you provided it, and you can get it from anywhere. Now we have something called SpanStream, which has been is in C++23, and means you can do something very similar with a completely different class. Again, thanks to Peter Summerlad. So you can create an OSpanStream, giving it the fixed buffer and the size of the fixed buffer, and then stream stuff into it. And then you've got os.span rather than str. So it returns you a std span, which has got the pointer and the length in, and then you can get data off that to get the pointer back. Or, of course, if you've got something that will accept a span, you can just pass the returned object in to that API. I don't think a lot of people have come across SpanStream, and partly because it's brand new and in C++23, but I thought it'd be worth highlighting that for some of these use cases. So if you've got a C++ interface that uses a string view, or of course just a pointer and length, then you can use it directly. So I could have a log method that takes some sort of string view and then just pass it straight in. And there's also an input span view, which again avoids needing to use a string at all, because often you've got some sort of, I don't know, packet you got off the network, and you've got a pointer and a length, and you can just pass that in. You can have an ISpanStream, which in this case is taking a stood string, but it's only using the effectively string view part of that. So I think my summary of this whole story is that StressStream is a good example of an unexpectedly long-lived class or header that had a bit of functionality that wasn't properly captured when the new method was produced, and it's taken us, well, 25 years and counting to get the thing out of the standard. So thinking hard about design can repay. So compilers have continued to support the old StressStream for many years, and people have had to continue to, write unit tests and maintain code for that. And if we'd got the job done better in C+98, there'd be 20 years less of maintenance of the old header. Any comments, questions about this one? No. Let's move on. Initializing objects, what's not to like? Constructors. Who's ever written a constructor? Yep, good. I think you're in the right room. So let's take a nice simple example. I've got a point, and it's got a couple of fields, int x and y, because coordinates are ints, everyone knows that. But I've got a double distance between this and the origin. And I can construct it from a pair, x and y, of separate ints, or I could construct it from a stood pair of int and int. I've just called a coordinate. All clear so far. And so I need to make sure that both those constructors work. So one way is to write them both out longhand. So I construct x from x and y from y, and distance from stood square root of x squared plus y squared. And I do exactly the same thing again in the second constructor. And you kind of think there's some near duplication on those calls to distance. There's also potentially other issues as well, but the main thing you notice is the duplication of distance. Can we avoid it? And the answer is yes, of course. One way of avoiding it was to do, I'm sorry, I apologize for mentioning this, but delayed construction. Yeah, don't do that. You want to do it in the constructor. In this case, the idea is distance and x and y are all immutable. So in C++98, one way is to write a helper function, perhaps called init. That's probably a name you might recognize. I've seen lots of things called init in code bases used for something like this. So you set up x and y, and then you call init, and inside the member function init, you set up distance to be square root of x squared and y squared, which is, it works. Is it better or worse than the original code? Any thoughts? I think it's an improvement, but we've got better tools in the toolbox now. Talking of better tools in the toolbox, my mouse is not one of them. So we can use non-static member initializers to express a constraint like this. So what we can do is we can say, in my class point, I've got int x, int y, and distance is the square root of x squared plus y squared. And I don't need to initialize distance any longer. It gets done by magic, by the compiler, which is close to magic, isn't it? In the implementation of the constructor. So what the compiler does is it looks at point with int x, int y, and it says you've initialized x, that's cool, initialized y, that's cool, and you haven't initialized distance, but I know how to do that. And you are allowed in the non-static data member initializers to refer to earlier declared fields and do operations on them. That's perfectly well defined. Reminds me, I was going to check what happened if you tried changing the order around, and I hope the compiler would tell you that is a very bad idea. I believe it does, but you need to check. And again, we've removed the code completely from the two constructors. It's a lot safer, a lot easier to refactor. Any downsides anyone can think of? A few hands go straight up. You've obviously done this for yourself. Philip?
You've got more code in your header file.
More code in the header file, yep.
You could use stood hypo instead of square root.
Yes, indeed. There's another library call I could have used.
Initialization happens in different places.
Initialization is split. Yep. I think, to me, that's probably one of the worst ones, is I've got some initialization happening in constructors and some initialization now happening in the class definition itself. Other comments?
You have to teach that it's possible.
Teach it is possible, yep. How many people here regularly use non-static data member initializers? Yeah, a few. Who hates them? A few, yeah. Who doesn't know what they are? Okay. So, who have I missed out? Oh, whatever. the header file must now include CMath. You've included extra dependencies. You also, if you decide to change the algorithm you use, so you don't want to use distance, use hypot, for example, then you've now got to recompile anything that uses that header file. So you're at the physical level breaking encapsulation to a certain point. I mean, it's still private, but you're partly breaking encapsulation. Only one place changes. Yep. So one option is you could add a static helper function that you call from the non-static data member initializer, for example, and then implement that in the implementation file. It's a technique to think about. Again, we're now writing extra code. We've had to write the non-static data member initializer, and we've had to write a helper function in the header, and we've had to implement it in the body of the code. Is the pain worth the gain? It depends. And then a philosophical question, if it's immutable, should it be const or not? Who thinks yes? Who thinks no? Who thinks it depends? You know, do people prefer them to be marked as const? Yeah. Who prefers them not to be marked as const? Okay. Any ideas why not? Well, I've put here a quote from the C++ core guidelines. Don't make data members const or reference, because it means that some of the implicitly generated member functions will now be deleted, because you can't, for example, assign one of these because you can't assign a const object. So you've now got something that you can't, you would have probably expected intuitively, a point. I've got point A, point B, can't I go A equals B? And now I can't because I've made them const. If they were non-const, then you can. Now the constraint that they don't modify is produced by the fact that I don't give any accessors that allow you change the object. So I don't necessarily need to make it const. Of course, if it were public data, the thing might be different. But that's a bit off topic for the main thing. I just thought I'd throw it out there. So knowing the different methods for initializing member data is good. And I like non-static data member initializers. I like them a lot. I think they're particularly powerful when you've got lots of different constructors to make sure that things do get initialized to a sensible default, or if you've got some sort of correlation between values and you want to do a kind of combined thing. But it does tend to leak implementation details out into header files more than you might want to do. Next one, using tuple and pair. Who's used std pair? Yep. Who's used std tuple? Yeah, good. Who's used both of them at the same time and torn their hair out? I can tell from the people without hair that it's happened. So they're both what you might call vocabulary types. So I nicked a definition from Titus Winters. The types that are most commonly passed through interfaces in a given code base, what we call vocabulary types, the most common generic forms of data. So one of the nice things about tuple and pair is you can take something that returns a tuple or pair, something that consumes a tuple or pair, and just glue them together. And if you used your own data type, it's probably a little bit more difficult. So a slightly made up example, using tuple, I've got a method called createEntry. I create a key and a value. I do some initialization that I haven't put in because it will make the slide too big. And then I just return a tuple of int and int, which is a key value pair. Okay, that's nice and generic data type to return. And of course, you do know that the first int is the key and the second int is a value. Will you still remember when you're consuming it? That's the downside with generic data types. But it means that you can pass it into other things and you can use the output in various ways and other tuples. But we do sometimes really want to express the intent in a way that's unambiguous to our readers. I mean, obviously the compiler doesn't care what we call it. Doesn't matter, not relevant. It's the other people that read our code that we're concerned about. Some years ago, I worked on a project where we had, I think it was tuples of tuples of tuples. And you were trying to refactor it because the middle tuple needed to have an extra element added. And it was like, okay, I've got get with zeros and ones and twos and working out which, it was just a nightmare. And it's again down to very expressive but not very clear. So we could, for example, say key value is our data type, and it happens to be a stud tuple of int and int, but it's now got a name, and the name expresses, hopefully, some sort of intent to the people reading our code. So we've now got our create entry returns a key value of key and value. Okay. In general, that gives you much better clarity over what's going on from the user's point of view, I think. Anyone agree with me, or am I on my own? I like doing this sort of thing. I like using, and using is so much nicer than typedef. Unfortunately, if you're using a very old compiler, you're still stuck with typedef. And we still have quite a few examples of code that uses typedef just because no one's bothered to change it for a long time. But using, I think, is a lot clearer. Or we may even just put key value in as a return type rather than auto, so that the user doesn't have to read as far to see what comes back. And in that case, we can remove the key value from the return and just have it automatically turn the braced initial set of variables there into key value. Again, we're implicitly creating a tuple, but we've said that up front. I personally think that is probably more readable than the original, but again, I think your mileage may vary. But it's a bit less pleasant when you're trying to consume a tuple. You have to do something like use get, and get with 0 and get with 1. And it's like, what are the semantics of 0 and 1? It doesn't say key value to me. Despite the fact the data type is called key value, there's no help in making it easier to read and reason about. So can we retain the flexibility and the kind of interoperability of the underlying data type and provide ways of expressing intent more clearly for what the fields are used for? So one way, of course, is to introduce some helper variables. So const AutoRef key equals std get diddly squit and const AutoRef value. And now it's much clearer to the reader of our code what's going on and that one's a key and one's a value. It's a bit longer. It optimizes really nicely because the compiler can see through the references and they just effectively disappear. And you can do the same sort of thing with std pair as well, because again, first and second, well, it's descriptive, but not very informative. But we could do something slightly different. We could perhaps go slightly further and create a helper class, which I've called entry, that takes two type names, T and U, and it's constructed from a tuple of T and U, and it extracts them out into key and value. Now I can use that as a helper type, const entry E, and then I can use e.key and e.value, for example. But I've had to write an extra class. Is it worth the pain? Don't know. But these sort of tricks had to be done. There wasn't really a good way other than that back in the day. Another way that people came up with when std tie existed was to think, I'll create key and value, and then I'll tie key and value together and assign that to the value of create entry to that, which binds key to the first element of the tuple and value to the second element. And now you've got useful names for them. How many of you have used that idiom? It's become reasonably common, or at least seen it in code. It also optimizes well as the compiler can see everything, and you know the end result kind of bytecode is just as good as you would get doing other things, and effectively the tie just gets eliminated. And there's no named variable here for the return value of create entry. In the previous one, I think my battery must be getting tired. I've got E as well as e.key and e.value. In this one, I've just got the name variables key and value, so there's kind of less ambiguity, less confusion, less potential for aliasing. But the disadvantage is if key and value aren't ints, but are something with a constructor that does something, I've got to construct them first and then assign to them, which might be silly, waste of time. So Since C++17, we've been able to use structured bindings, where you can go, in this case, const auto key comma value, so two variables in square brackets, equals create entry, and the compiler under the covers unpacks it into two variables called key and value, which is great. Nothing not to like here. It's really nice. We've got these named variables. We've got a descriptive name for them. And we've still got the fact that create entry is returning a generic data type that we can pass into generic methods that expect a tuple. And under the covers, it's approximately equivalent to the first code I showed, where we get back an unnamed variable, _v, that is of type, actual type, std tuple, and then we just do const ref key and value. I mean, approximately equivalent. A lot of hand waving here. But it's sort of doing what you can do yourself, only better. Wouldn't it be nice to be able to use structured bindings with variadic tuples? For example, inside a template where you may not know how many arguments you're going to be invoked with. So I want to pull out my create entry. It's been made more generic to have a create entry of a list of types rather than just a hardwired pair. And I want to assign that to auto ... items. I'll now have a variadic variable for items. And that was proposed in structured bindings to introduce a pack, which should be coming in C++26. So you'll have to wait 3 years probably for that, although some compilers may implement it before. If I remember correctly, it's ready to be voted on as soon as we start voting on papers for C++26. And in general, the std tie solution that people have been using for quite a few years, in general, I think is better now done with structured bindings, because you're not having the problem of the variables being initially declared without an initializer or possibly default constructed. There's still a couple of places where it could be useful. One of them is you've got a data type transformation you want to do, because you can only do a structured binding with auto. So you get the exact type that's returned, and you may have a reason for wanting a different type. And the second one is if you're wanting to update some variables you already have. So the example I came up with was if you call create entry and then stuff happens and you want to update it, you might want to use std tie, because you're actually wanting to overwrite the existing values of key and value that you've had already. But in general, a lot of the uses of std tie can go away. Might be better off just not trying to use this. And using tuple itself is getting easier with class template aggregate deduction and some of the other changes that are coming down the path. But it's still, structured bindings, I think, are a great step forward. I think I'll do rules of n, yeah. Quick one on the rules of n. Who's come across the rule of 3? Those who have used C++ for a long time. And the rule of 5? Yeah. And the rule of 7? Just guessing. Rule of 0? Yep, yep. N? Whatever. It's a hard choice sometimes when you're designing a class. You've got constructors. You've got more constructors than you probably want to care about. You've got the implicitly defined ones and declared ones, and you've got a destructor, and you've got assignment operators. And way back in C++98, in fact, even before that, as you can see from 1991, Marshall Klein came up with this rule of 3. If you define any one of the destructor, the copy constructor, and the copy assignment operator, you should probably be defining all of them. And I mean, 3 is a small enough number. I mean, it's one too many, but it's still a small number, and you can cope with 3, and it's not too much extra work. So a standard example would be something that owns. So in this case, I've got some sort of packet, and it contains a pointer to a char array, which I'm creating in the constructor. And now I've got to think about ownership. And if I copy it, I need to copy the packet contents. And if I move it by assignment, I need to make sure that everything happens correctly. And when I destruct it, I need not to leak memory. So I've got to make sure I get rid of it. So I need to think about those three methods. That's not too difficult. There's only three to worry about. So a typical implementation might be to delete the buffer in the destructor. That's the one most people would remember. And then in the copy constructor to copy the length and then create a new buffer, the same length as the other one, and then do memcopy. And then in the assignment operator, you could use the swap idiom, something like that. And it's not too bad. And I mean, three methods fit on a slide, so it's all good, right? But then we added move semantics. Now you've got the move operators to think about as well. So n plus equals 2, going to need a bigger boat, more thought. And how to implement the move constructor and the move assignment operator often are slightly more difficult to reason about and think about. And we've got much less experience of writing them. And what actually is the move from state for our class? Not sure. So first off, people just generalize rule of 3 to rule of 5. And if you wrote one of destructor, copy constructor, move constructor, copy assignment operator, or move assignment operator, then you should do the other 4. And then people started thinking, actually, this is getting really out of hand. You get a lot of cruft in the header, and you get a lot of code to write. So the first one was to change the rules slightly so that if you don't declare the extra members, they're not declared for us. So once you've got a copy constructor and a copy assignment operator, then some of the other special member functions don't get defined for you. Again, the precise rules of which version of C++ did what will vary slightly. But if you do need to implement them, then for example, in this case, we could say, well, if you move from our packet, we now set the buffer to 0, or null putter. But now I've got to start thinking about all these changes that my class has. I've now got to move from packet with a buffer pointer of 0. I didn't ever have one of those before. So my preconditions have all changed. It's got more complicated. The move assignment is, again, I can just use the swap paradigm. That works quite nicely. But this could be a bit of a time bomb. So the single responsibility principle says, well, let's not think about it. It's someone else's problem. Delegate to a helper object. So let's make someone else own the memory. Depending on what I pick, I get different behavior. So pick the right type. So here, for example, I've decided I'm going to pick a vector of char. And vector will come with a set of semantics for copying and assigning and moving that I inherit from vector, and I don't need to write any special magic in my class to cope with the move and the assignment semantics. I get those based on what sort of type my buffer is. So we've got just the normal constructors. I haven't had to think about any of the copying and moving and assigning and destruction. It's all done for me, which is where the rule of 0 comes from. Unfortunately, sometimes we need to write a destructor and then we have to at least name the other 4 methods, which is a bit of a pain, but that's the way it goes, sadly. So the best case for the rule of n is when n equals 0. And I think one of the things that I've noticed is a lot of people don't really think hard enough about the ownership, things in your class that have some sort of ownership. You could write a very simple helper class, perhaps even a nested helper class, that just does the ownership. And then your main class, you may not need to write any of the special member functions in it. They just get inherited from the special member functions of the members of your class. And again, when moving from older C++ to newer C++, again, my experience is, I mean, I've done it, I suspect some of you have, is you think, oh, I need to add move semantics to this, rather than I need to take away copy an assignment and delegate to a helper object.